Okay, so we're given a problem asking us what is the current at the following times at 1, 2 milliseconds, and 2 seconds flat. Now the good thing is that we're given the magnetic field as some sort of rate of change with respect to time using an exponential decaying function. We're given the number of turns in the coil and an area created by the system. Now the first thing we have to do before we jump into finding the current, we need to find the voltage, which is given through the negative rate of change of the flux with respect to time. And the magnetic flux is given as the number of turns times the magnetic field times the area times some angle in reference of the magnetic field entering the coil. Now the good thing is that these two are orthogonal, meaning that if we plug 90 degrees in here, it really just cancels out as being 1. Now the number of turns in the area are constant, so you can actually factor those out, and you're left with the rate of change of the magnetic field with respect to time. And after plugging every single constant into it, we get a positive value for our constant right here, along with this rate of change. So the only thing left to do, well, half of the things left to do is plug in these numbers into this function to actually find the voltage at those times. And we see that after 2 seconds, our voltage is virtually 0. So it's a very short burst of electricity into this particular coil. Last thing we need to do to actually find the current is just apply Ohm's law, but in this case solving for the current, where we can actually plug it in divided by the 6 ohms given at the beginning of the problem, and we're left with 0.696, 0.7 amperes, 57 amperes, 0.57, and of course this value is 0, so we're left with only 0 amperes in the end.